Alright, so today is the 27th, all day long. We are going to go over 9 and 10, but I'll really go over anything, especially as we get further into summer school. So, reminder for how face-to-face class sessions work. 9 and 10 is our top priority because that's where, in progression of the calendar, we should approximately be. This is a lie. That's what I get for loading up the same one. So, you want to be ready for chapters 11 and 12, ideally. Don't freak out if you're not. But you also have longer for that because that class is not until July 11th. So we do not have face-to-face class again until July 11th. There's no office hours Friday of this week or at all next week. The building is locked and closed. You cannot come in next week, to make that exponentially clear. If you come in, you will be very disappointed. You will not be able to get in the building. No one's here. They shut down summer school for a week. So, that all said, let's talk about 9 and 10. So, any questions from chapter 9 work? Any of the practice? Did we do G's or K's on that one? G's. I just like those better. They're very similar. So, there were only 4 sections, 9-1 through 9-4, but any questions? I'll just pull it up and see what it is. It's not what? I'm logged in. What are you doing? Are you kidding? Perimeter, circumference, graphing figures, and then finding it. Yeah. Question 8. Oh, 9-3. Let's go one section at a time. So anything 9-1. Finding area. A lot of this is review stuff. We get into some more complex shapes, where previously we would just have straightforward shapes and you have to figure out the missing sides. Circumference and area of circles. Nothing from 9-1. Going once. Twice. 9-2. So parallelograms and triangle areas. Finding the missing height or altitude of a parallelogram, because if you can actually choose 2 different altitudes, so that's one thing to make sure you realize here. We have one altitude given to us if this was our base, but if we use this as our base, then the altitude would be here. So those are the missing altitudes. Area of triangles, 1/2 base times height. Remember, base and height are perpendicular, and in geometry, there's no up or down, just like in Ender's Game. So you can rotate, you can move things, so base and height are given to you here, even though it looks kind of awkward. Questions on the back, anything? Logos, complex shapes, area of polygons. Remember, our distance formula is just a manipulation of the Pythagorean theorem. Anytime we're working in the coordinate plane, remember that you can set up right triangles to make your life really easy solving that unknown distances. Nothing 9-2. 9-3. You had said which question? Anything before 8. So this is actually going to utilize some special right triangle work. So let me zoom in on this and take it over to Smartboard. So when we see that 30-degree angle, that should kind of be an indicator for us. All right. So here's where you want to frame your brain is, okay, what do I know what can I figure out, and what can I utilize to figure that out? So, anytime I have a complex shape, I like to think about breaking it up. Here, I really have a rectangle, might be a square, I don't know yet. I have a rectangle and a triangle. Now, this triangle I'm given some information about. I have a 30-degree angle. Something else that we can figure out is that we have a 90-degree angle, because if I drop the vertical, then I know it's vertical. So now what I've created is a 30, 60, 90-degree triangle. Now, what special rules do 30, 60, 90-degree triangles relate back to?
It's like the sides are like A and then 2A and then A radical 3.
So for review, because I know that not all of us are remembering it, even if some of us are, you can always just Google special right triangles, and I will tell you, going straight to images is almost always your best bet. Because there's really good stuff. And what's interesting about Google and YouTube being like coupled now is I will occasionally randomly find things from my YouTube videos that somehow have generated into Google Images because it pulls snapshots out of people's videos. So if you look up the special right triangle rules, here's a really easy representation of it. In a 30, 60, 90, my short side, it's kind of fuzzy. In a 30, 60, 90, those are all leg rules. There we go. 30, 60, 90 triangle. My hypotenuse is twice my short leg. Now, this is kind of a weird way to remember it, but this is how it works in my brain. How do 30 and 60 relate? One's double, right? So, now I know that's not your biggest angle. This is where you got to kind of let your brain do a little bit of like matching of things that don't quite line up. 60 is twice of 30. Your hypotenuse is twice your short leg. They don't match up quite perfect, but that's how it works for my brain. However it works for you is fine, but that's how I remember the 30, 60, 90 rule. 60's double 30. My longest leg, my hypotenuse, is twice my shortest leg. So now knowing that, we can come back here and say, well, I know my hypotenuse is 10 centimeters. So you asked for this. What else can I then figure out if I know that hypotenuse? So then this would have to be 5. From there, what can I figure out? Well, if I want to break up my complex shape even further, that long line on top, if I pop back to that rule, well, okay, my other leftover leg is that x value, that small leg, times radical 3. The other way that my brain remembers this is these are all divisible by 3, well, and the fact that it's 30, 60, and then 90. So that radical 3, this is just kind of one of those things you got to figure out how to memorize it in your brain. What little trick can you remember? But my long leg, not longest, because that would be my hypotenuse, but my longer leg, right, where can we do this? Purple, I guess, is going to be that 5 times a radical 3. And from there, I could figure out what's left over of that 14. So 5 rad 3, 8.66. So then what's left over here is the difference there. And 14, if I plug in my second answer and get a really precise one, 5.339, so about 5.34. Now the base of my triangle is easy because it's 5. The height's awkward. Now there's always multiple ways to do this. So if you don't like that way, you could figure out another way. That's probably the easiest though. I mean, another way that you could approach this, if you really wanted to get crafty creative, and this would be something I might give as like, well, I don't know if I'd give it as like a challenge problem. But let's say I gave you that again, but said you can't make a rectangle. Well, we could actually draw a line parallel to this line and the same length. I mean, just talking about other ways to solve. I could drag this over to this point and make a parallelogram and a triangle. And I still have a 30, 60, 90 triangle. And I can still solve exactly like I did. And I know that this is still 10. So the way that we can break this up differently is that 30, 60, 90 will still have 5 and 10 right there. And this longer leg was 5 radical 3. And that looks crappy. And then this section that was left over, or no, yeah, would that still be 5 radical 3? Yeah. So then this was 8.6 or something like that, and then you could solve with the parallelogram. You'll get the same answer. So don't trust those exactly because I'm working really quickly, but it'd be approximately like that. So you've always got multiple ways to approach this. Yeah.
Would it be okay? I did
You're fine. It's Disney-ish.
well, I did 30 sine times 10.
So if you understand trig, then yeah, you can use the trig. So trig is really like a math 2 thing. So to dabble in it for just a moment. Do you want to explain why? So tell me which trig function you used again.
I did so, which is
Sine, yeah. So
sine. So I did sine times 30, which I think is 0.5.
and what is that going to be equal to?
That's going to be, well, times 10 is equal to the height.
So trig comes down to one saying that you'll probably hear over and over and over again in your mathematical career. SOHCAHTOA. Now, SOHCAHTOA is a really simple way to explain the ratio relationships of our trigonometric relationships, not to be redundant. But so trigonometry is how angles and lines relate to each other. How the length of a side of a triangle can be determined by the angle size and the other pieces. So the fact that I know this 30 degrees and I know that 10 centimeters, these are related to each other. So I can use sine of the input angle. So it tells me sine will equal opposite over hypotenuse. Cosine would be adjacent over hypotenuse. Tangent would be opposite over adjacent. Now, if you don't understand trig, don't worry. It's more of a math 2 thing. I'm just going there because Cassie brought it up, and I love trig. Probably one of my favorite mathematical topics because it's really, really useful and it's really, really easy. So what Cassie was saying was if I multiply by 10, I get the opposite side. Well, that's because if I set up this ratio, the opposite side, I don't know it. My opposite side of the angle is unknown, so I leave it as some x, but my hypotenuse is 10. So forget about this middle part. If I had sine of 30 over 1 equaling x over 10, I can cross multiply, get x times 1 equals 10 times sine 30. So my unknown side will be 10 times the sine of 30. Now you have to make sure that your calculator is in the right settings. This is where trig gets dangerous. Your calculator has settings for degrees or radians. We're plugging in degrees, so you'd want to make sure that your calculator is in degrees. That is 0.5, and then you multiply that by 10, and you figure out that that unknown side there is 5. Same as using the special right triangle rules, which actually special right triangle rules are kind of a derivative of the trig relationships. Sorry, that went a little deeper than we needed to, but if you look up how to utilize trig, it's not too big of a learning curve. And you could use some Khan Academy stuff or whatever. If you want to learn about trig, Go for it. Ellie?
It says Sakato on the board.
So?
Yeah, it looks like Sakato though.
Looks like what?
Sakato.
Okay.
My old math teacher said it.
So, if you want a better way to write it, and like a, forget who, somebody used to do like that. So you remember that it's actually this equal to that over that, but there's an angle measure or a radian measure that has to plug in with your trig function. So don't get, like this is where people screw up. They'll just write sine equals. This is not true. This is not true because that doesn't make any sense. Sine is not a thing. It is an operation. It is like a function. It has to be operating on something. You have to have an input of your angle, which we often use the Greek letter theta for any angle input. So you would have to have the size of your angle. Or, if you don't have your angle, you have to have the other two sides. And then you can find out your angle, which that's really nice because trig works forwards and backwards. You can either find out sides or find out angles. All right, all that on that single question from 9.3. Moving on, anything else from 9.3? Oh, and leave it in simplest radical form. Anytime it says that, that's like a red flag. You're going to be using square roots, radicals. So that radical 3, we should not have done the multiplication. Sorry, I should have read that. We should have just left it at 5 rad 3. But if you do it and you give me a decimal answer, that's okay. But this is trying to make it easier for you. You don't have to multiply out. You don't have to work with messy decimals that go on forever. Leave it in rad form. So that makes your life easier. Area of kites. Kites are just pairs of triangles. Area of rhombuses. Rhombi. Trapezoid. You always remember trapezoids because they look like a trap. You've ever seen like a live animal trap or something? Finding coordinates, or finding the area. Again, you can use Pythagorean theorem if you need. Over here, 26, you might need it. You can also always just break up these shapes into easier shapes to deal with. If I really wanted to make 26 easier, I could honestly break it right here. And this gets a little funky. There. There. I don't know why that's crooked. And, ooh. It's going to be tough. Go for it on the line somewhere. And now I have 4 triangles, because if I don't cut that one there, I have this awkward shape in the corner. That's the only really awkward one left. But I could even break that one down further if I zoomed in on it. You can always break your complex shapes up. Now, that's not the easiest way. Once you understand how to work with these shapes, it's easier to just deal with the shape as it is. But I also don't need to break it up that far. So I could break it up into some other set of shapes and work with it from there. Anything else from 9.3? All right. 9.4, wrapping up the lesson, dealing with polygons on the coordinate plane. I don't like saying in the coordinate plane. It sounds weird. In a two-dimensional space. So, by the way, I don't know if I showed everybody this trick. It took me a long time, I don't know why, to remember scalene isosceles and equilateral. And if you've ever seen this trick, a previous student of mine told me this, so you can thank them for blowing my mind and forever improving my math abilities. How many equal sides does an equilateral triangle have? Just shout it out. How many equal sides does an isosceles triangle have? How many equal sides does scalene have? None, right? So every side is unique. 2 the same, 3 the same, none the same. A student told me that and it blew my mind. So one of their elementary teachers taught them that. But scalene, it just sounds weird. You should be able to remember scalene's the weird triangles. But isosceles has the 2 for the top and bottom of the eye. Equilateral has the 3 for the parts of the E. Question?
Isosceles has 2 S's.
Oh, that too. But then how does equilateral play into that?
Equal.
Well, yeah, they're all equal, but if you understand your stems.
Yeah, but everybody knows.
Okay, everybody.
I mean,
Anything from 9-4. So that's your scalene, isosceles, equilateral. Most precise classification. Sometimes quadrilateral is the most precise if it is nothing else. So it's like a scalene quadrilateral, quote unquote. Short answer responses. Still, to be an isosceles trapezoid means that the 2 sides are the same. So it'd be this and this, A, B, and D, C. So whether it's triangle or larger than that, isosceles means 2 the same. Plotting these on the coordinate plane. Now, if you use colors, somebody asked me, do I have to use different graphs for each of these? No, you can put them on the same graph. You just want to keep your brain straight. I would use colored pencils or something, and maybe rename these points like D, E, F, G, H, I, J, K to help you like not get totally on top of each other, or just make a couple different graphs. Checking congruency in the triangles. Any questions? 9-4. Try and get better at wait time. Chapter 10. Did we G or K on 10? Oh yeah, I should probably pause it for 9. So I'm gonna stop this video here, and then we will pick back up for video for 10. So this was your review of chapter 9.